Good morning, this is Josh at Mass Gunworks. I had the distinct pleasure of working on a very cool historical firearm. It's one of my favorite historical guns to shoot. Wanted to take a minute and share it with you. Before I do that, thank all of you who have been watching, commenting, subscribing, giving me thumbs up. I really appreciate you guys. I love doing what I do on this channel because it gives me an opportunity to do one of my favorite things, that is teach and share what I learn along the way with you. And I really appreciate the interaction I get with you guys with the comments. And so that being said, if this is a video that you found helpful, when we get to the end of it, please give me a like, excuse me, subscribe. Feel free to leave comments. As I always ask, please keep them respectful. I don't mind at all if you disagree with me, want to have a debate about something. In fact, I encourage it. Just keep it respectful. So without further ado, M1 Carbine, also known as 30 Carbine. This rifle is iconic. It's amazing. And it is an absolute joy to shoot. It is what I believe they refer to as a light infantry rifle. I hope I'm saying that right. This rifle was in service with the United States Armed Forces from the early 40s, I think around like 1941, 1942, so World War II for sure. And then all the way through, I believe it saw some very brief service, Vietnam before it was mothballed, but for sure WW2 in Korea. So it fires a 30 caliber bullet out of it looks like a straight wall cartridge. It does have a very slight taper to it, but it fires a 110 grain full metal jacket bullet out of a straight wall cartridge. I would say it's equivalent to a 300 blackout. 300 blackout's got a little bit more velocity and fires a heavier bullet if you're doing subsonic, but it's very comparable. It's got a gas system that is similar to an M1 Garand. It looks like a baby M1 Garand or baby M14. There's a lot of cool history behind it. I'm not going to go into all that, but if it's something that you're interested in researching, please check out Forgotten Weapons channel. He's got an amazing 25-minute video about this. And then as I get into the things I've learned about this and some of the stuff you need to watch for when you're working on them, there's a guy, Norwich 93 CMP. So Norwich, the number's 93, and then CMP. That's his channel. His grandparents were both armorers in World War II and worked on these rifles, and he is a wealth of knowledge, especially when it comes to the military issue types. So I've got some notes up here on my marker board. We've gone through the brief history, all that kind of stuff. So this rifle, I needed to rebarrel it, okay? They're not insanely difficult to work on. Just you need to make sure that you're getting correct stuff for the correct one that you have, because I'm going to jump ahead on my list a little bit, but there are commercial variants that are made under commercial specs, and there are mil-spec ones that were issued and are sold to the public through the civilian marksmanship program. They all look the same. Mostly there are some variants in design throughout the evolution of this, especially with the military variants, but for the most part, they're all pretty standard, okay? The one thing that I ran into when doing this rebarreling was I always ask, okay, why? Why are we having to do this? What led to this? I have a bit of a investigative mind, and I want to know why I'm doing something before I just go take care of it, in case the customer has been misled and we're doing a repair that isn't going to take care of the issue. So this gentleman felt that he needed to rebarrel this weapon, and after an examination, I deduced that the problem he was having with it not firing was related to the fact that the gas system was not set up correctly. So the gas system on this, you have this is the barrel I took off, by the way, and I'll show you why we had to change it. But this is the gas block. So when the round is fired, the chamber's here, bullet goes down the chamber, and when it gets to this point, some gas is siphoned off and it hits a piston setup. Okay, that's in there. And this piston is typically in this configuration right here when the weapon's inert. But when it's fired, gas acts on this piston goes boop, and it flies the operating rod and the bolt and carrier back. So this gas block, it's very similar to the way an AR-15 operates, minus the piston. I understand direct impingement, gas piston, whatever. AK-47 may be a closer comparison. So this gas block is silver soldered onto this barrel. It's made of a piece of steel and has threads in here, gas block threads in. I believe this gas block is half-inch 32 thread pitch. It's a very odd thread pitch. It's not something you're going to go down to your local hardware store and buy. So if you have one of these, you're working on the gas block, you screw the threads up, you can order a tap from McMaster's Car. You can order a tap off of eBay, and I believe I found some on Amazon as well. There's some places like Franklin Arsenal that have a specialized tool that precisely lines your tap up with this hole. That way you get everything straight, because with these being extremely fine threads, it is easy to screw them up. So anyway, that being said, as I was examining this and learning about the gas system, I noticed that the gas port, block, was all messed up. Okay, so what had happened, something had caused this to blow out. And I also noted that this had already been welded back together once. So this was not the first time that a person had this issue with this weapon. And then the gas block, the gas piston setup had been welded in place. I don't know if you can see that bead of weld. And this piston right here, the head of it was mushroomed over, which may be a common thing with this weapon, but I was assuming not. So thought we got a problem here. So I started checking things, and one of the things that I checked was the headspace. So I bought a headspace gauge, and I just headspaced the barrel while it was in the weapon. Used the bolt and op rod to hold it and whatnot. So what I found was the headspace on this barrel specifically was a little bit too tight from the factory. So because getting it from the customer, I was led to believe that he was the original purchaser, the original owner, and nothing besides the gas piston setup had been changed by him. So the barrel was probably original. So he provided me with a new barrel. Okay. He ordered this directly from the Civilian Marksmanship Program located in Anniston, Alabama. Anniston, Alabama, for those of you that don't know, is the hub where they deal with a lot of the 30 carbine stuff, to my understanding. I called down there, talked to one of the gentlemen there in the shop. He's an armorer. Wealth of knowledge. If you ever have any questions about any civilian marksmanship program weapons you buy, call them. They're great to work with, and they'll answer your questions. So, had a pleasant conversation with him. So these barrels, we're going to get into some differences here. So the commercial and the mil-spec barrels are made differently. So these weapons were commercially produced for a period of time in the mid 60s, late 60s, through the 70s, and then production stopped. This one was manufactured by Plainfield Machine in Dunellen, New Jersey. Okay, so this was a fully commercially produced item. There was a little bit of crossover between specifications and parts, but the longer they started being commercially produced and the less the mil-spec parts were available, the more that the individual manufacturers started kind of making their own specifications. So anyway, one of the biggest differences is a commercial barrel, the chamber face looks like this. I mean, completely smooth. There's, nothing sticking up, hanging over. The mil-spec barrels have what they call a skirt, and there's a short skirt and a long skirt. Watch Norwich 93 CMP's video. He goes into a lot of detail about that. So I drew a little cartoon here on the board. Shows, so your chamber is here. This is a threaded tenon that threads into the receiver. The skirt is this feature that sticks up, okay? And it's approximately 80 thousandths long. And it goes about a quarter of the way or less around the chamber. And everything I've read so far, the only reason it's there is it helps support the bolt, which in a military application where you're going to be firing this thing a whole lot, probably a good idea to have some bolt support. Commercial application, you're going to buy it, stick it in your safe, get it out, fire it a couple hundred times a year. Probably don't need to be built as stoutly as ones for the military. And in the commercial world, if a manufacturer can save a buck, they're going to save a buck. So taking that feature away probably saved a step or two in the manufacturing process. My guess is that's why it was taken away. So as I was talking to the civilian marksmanship people, I told them the brand of receiver I had, and they said, well, that's a commercial receiver. So what you'll need to do is mill the skirt off of it. Should fit up fine. Okay. Did that. Didn't work out. The big issue there came into the head spacing. So one of the things that I would advise you to do if you're doing any work on firearms and you have a lathe or a milling machine, get some aluminum that's 1.5 inches, 1 or 2 foot stick. Just have it laying around the shop. There's a lot of uses for that. One thing I did, because I needed a reference point to measure headspace off of that was nice and flat and square, when I had the barrel out of the weapon, was a gauge block. So I just took this. It doesn't matter how long, you just need a true reference point. So this is probably 1 inch, and the receiver threads on this are 3/4 by 20. So 3/4 inch diameter tenon, 20 threads per inch. And I just tapped it with the 3/4 20 tap that I have. So what that did is it gave me the ability to take this, put it on this barrel, and we're going to tighten it all the way down to the shoulder. Okay, I'm going to show you the variances between commercial and mil-spec. Now mind you, this commercial barrel I put on, I headspaced it, I've fired the weapon, run about 10 rounds through it. It runs great. So I know that it operates just like the commercial barrel did. So I'm going to put my micrometer on here. It's a depth mic, and we're going to get a base measurement off of this one. And I can tell you from doing this before I started filming, this one measures at 789 thousandths. Now that's off this gauge block. And again, this gauge block is not a true representation of the receiver. It is just a reference point, okay? I'm going around to a couple different spots here, just checking. It's really good to do that. It's about 788.5, 789. So now we're going to put it on the other one. The reason this is important is because this barrel, when it's, well, this gun is manufactured to headspace off the front of the cartridge. Okay, so I believe it's called the shoulder of the cartridge. Or not the, it doesn't have a shoulder. It's meant to headspace off the very front of the cartridge. So do this one, run it down. Okay, so this one's about 786, 787, so there's about a 2,000th of an inch variance. I know that doesn't sound like a lot, but that can make a difference when you're trying to headspace. And I can tell you that when I went to rotate this barrel onto the receiver and hand tighten it, when I got it hand tightened, I was clocked. So here's top dead center. I was clocked 90 degrees to top dead center, okay? That's a lot of turn to make up when you're trying to torque something down like a rifle barrel. Typically what you're gonna see is you're gonna be able to hand tighten it within 1/8 of a turn or less. So you'll be approximately 45 degrees or less off your top dead center. So this one, again, this is just a representation. This is my receiver end, top dead center. Things are clocked where they're supposed to be. This barrel would have been about right there, okay? So the civilian marksmanship program barrel, the actual mil-spec barrel, was all the way up here at 90 degrees. This barrel was about right here. Okay, and so was the other barrel. So I'm going to drop the headspace gauge in now, and I'm going to measure off the back of the headspace gauge. These headspace gauges, just as a little aside, are kind of an odd shape, but they're meant to be used with the extractor and the ejector still in the bolt. So that's kind of why they look weird. But as you can see, it's just a flat square face there. And this would be the end of the cartridge where the bullet is pressed in, and you got that little lip there, the front of the brass, and that's what we're headspacing off of. So I'm gonna drop this in my chamber on my commercial barrel. Okay, so this one is measuring 508 thousandths off the headspace gauge. Okay, this one is measuring 527 thousandths. Okay, so there is nearly a 10,000th of an inch difference between the head spacing on this mil-spec barrel and the head spacing on that commercial barrel. So another thing that you can check, and I just did this because it doesn't really bear any credence here, but so I've got a 10,000th, yeah, almost a 10,000th of an inch difference between my head spacing. Okay, that may not sound like a lot, but that is enough that I would potentially have to do one of two things. I could go in and I could shave some material off the back of the bolt face where the cartridge butts up against the bolt face to make it a deeper pocket for the cartridge to set in. That's not advisable. You've got a little bit of wiggle room there that you can play with. You can take 2-3 thou off, but 10 is getting a little adventurous. And the reason I say that is because you may have enough of that cartridge hanging out of the chamber that it's not properly supported, okay? And you could cause a case head failure. The cartridges, the brass, if you look inside of it, the base of that where the primer sits is solid, okay, except for the hole that's made for the primer and for the ignition to go through. It's a solid hunk of brass, and that solid hunk of brass is all that's hanging out of your barrel typically. When you get above that, you get into the cavity, the cup that's formed for the powder, and if that is hanging out of the barrel as well, you create a potential for failure, because now you have that gas from the ignition expanding, and if it presses that case wall against the chamber, and say like half of my chamber is supported, or I'm sorry, half of my casing is supported by the chamber wall and half of it isn't, the half that isn't is going to continue to expand because it doesn't have a stop, and it's just going to fail. So that's why it's not advisable to just deepen the pocket in the bolt that the case head sits against. What you would want to do this properly would be to take a chamber reamer and ream the depth of the chamber deeper. So I was not going to do that. That would be a lot of extra cost to the customer, a lot of extra time, and it just was not a prudent way to fix this issue. So what I did is I got on eBay and I found a barrel that was made for commercially manufactured receiver, okay? And it worked great. So the other thing that I noticed when I was examining this rifle and taking it apart is there are two different types of gas systems. I apologize, this video is going kind of long, but there's just a lot of information I've come across and want to share with you. So it may be a little hard to see, but this I don't know what the technical name of it, but it's the nut that holds the gas piston in. You see that lip? That allows the gas piston to protrude probably an additional 20 to 25 thousandths of an inch. Okay, this is a different style. This is what I believe to be an older style, and it's completely smooth. So your gas piston is going to just stop right there. Okay, so what I believe occurred is because the weapon was headspace a little tight to begin with, it started causing some issues with the op rod and the gas piston running. And over time, it was hitting harder than it should have, fractured the gas block, and led to this failure. So the guy probably just got another one, swapped it out, welded it up, good to go. But he may have potentially used the wrong type of gas piston nut, and now you have extra throw in your gas piston, so it's able to travel a little bit farther, so it's hitting harder, which means it's also putting added stress on the metal that's holding it in place. So that probably, again, led to the fracture and the failure of the weapon to operate correctly. So when I purchased this barrel, it came with the gas piston and with the retaining nut, and I took it apart and examined it, and what I got was this style right here. Smooth face. The pistons are nearly identical, so there's nothing there. But now that we've gone through all that, suffice to say, if you have a 30 carbine or any other historical military firearm that may have been produced commercially at some point, you need to do your due diligence, study up on it, figure out whether it has commercial parts or mil-spec parts. Call the Civilian Marksmanship Program. They're great people. They'll answer all your questions. They'll give you the specifications that you need to measure things out if you want to measure them out. Make sure you have the right tools. I bought this wrench. It's a special 3-lug wrench for taking out the gas piston off of eBay. It's $15. If you ever go to remove your barrel, you're going to need the special block for holding the barrel, and then the special wrench for gripping the receiver. Okay, these parts will probably run you, depending on who you get them from, between $90 and $190. I bought a different style tool, so it costs a little more, but it supports the receiver a lot better than the old style. The last thing I want to do is show you how to break this down and tell you about some differences in the receivers, and we'll call it a day, because I guess that's getting kind of long. So the first thing you want to do is obviously operate the bolt, make sure that the weapon is empty. Hang on here. There we go. Okay, so we're empty. Then we're going to come up here, we're going to loosen this screw on the barrel band that supports the wood. All right, we're going to loosen that up. We need to push this spring clip in. Okay, sorry. That spring clip retains the barrel band. And this one fits tight enough that I have to use a screwdriver to push it in while I use a rubber mallet to drive off the barrel band. It's a pretty snug fit. Some of these don't fit as snug. You don't have to do this. This is the variant with the bayonet lug. Before I do this, your front sight, so there's a pin that holds the front sight in place, and then there's another pin that sits in a keyway on the barrel, and it has a slot cut in it so that this pin goes through that slot and lines up just perfectly. Okay, so we're going to take this wood off here. There's also a screw back here. You do not have to take it out. You can if you want, but you don't have to. So this just rotates out. Okay, there's my barreled action trigger group, right? We have one pin right here that holds the trigger group in. Comes out pretty easy. Trigger group, just kind of, you got to make sure the bolt is activated, or sorry, the hammer's back. So it just slides out, okay? This is your op rod, bolt, recoil spring. Recoil spring, pull it down, gently move it to the side, pops right out. Operating rod, there's a cutout right here. There's two lobes. You're going to come down. Actually, I may have to take the bolt off first. So the bolt, there's a cutout right here. You're going to come down and line that up. And the bolt. Okay, now we can come over here, and this just rotates off. Okay, once you get your lines lined up and the bolt out of the, just rotates right off. Okay, your bolt, you're gonna bring it up. You kind of got to play with it a little bit to rotate it and get it into the correct position to pull it out. But there we go. Okay. Now the bolt's kind of interesting. So you've got this detent and it holds in the extractor. The extractor is a big hunk of metal. That also holds in your ejector button and your firing pin. Okay, so it does a couple jobs. So that is a stripped action. All right. So one of the main variations, Winchester was the original one to start making this rifle. This tube right here that your op rod, or I'm sorry, not your op rod, your recoil spring guide rod right in is one piece. It's machined into the receiver. On some of the older original variants, this was not machined in the receiver. There was a cutout here and there was a separate tube that went in. And when you went to remove the receiver from the action, you had to be very careful about how you did that, because you could potentially over torque and twist or break the receiver with the wrench. So this wrench that I bought, the reason I like it is because it's got an extra cutout here, and no, I'm sorry, it's an extra cutout here, this square notch, not the round one, but this square notch. So what you're going to do is you're going to line up the half round notch with the recoil spring tube on the bottom of the receiver, and you're just going to slip it on. Okay, and this wrench here is made to also support this recoil lug, so you get a little bit of extra support. Typically you should be able to put your barrel in your block here, torque it down, put it in a bench vise that's securely fastened to your bench, and put your receiver wrench on and you should be able to spin it off with your bench vise holding all that. You're probably looking at somewhere between 75 and 100 pounds of torque. So you may need to hit it with a dead blow, the wrench handle, to get it to come off properly. When you go to put it back on, be sure that you do not over rotate. Pay attention if you need to, make some witness marks. Most of these receivers will come with a bottom dead center mark on the center of the receiver, and the barrel should have a bottom dead center mark, and you just line those up, okay? The civilian marksmanship program guys, they said that what they like to do is take and get this all set up in a vise, take the rear sight out, put a level here, and then run a gauge pin through these holes and put a level on that gauge pin. And then they're able to get everything leveled and clocked correctly. So, yeah, that's all I got. So we'll put this back together real quick and we'll be done. So we're going to start with the op rod. Take the op rod. There we go. Slide it into place. All the way back. Get the bolt in. Okay. This is always the hardest part for me, is getting the bolt and the operating rod back together. It's best to have the bolt riding in front of the operating rod, and they just slip together. So next we're going to put our recoil spring and guide rod back in. It just slips in this hole. There we go. And there's a little right there. Operates good. You can see our gas piston right here. Okay. And then we have our, I believe that this is going to do better slipping in from the rear. So you don't want to like put this on and rotate it down. Just line it all up, slip it together. There is one side of this. So if you're looking at the weapon like this, the pin is going to go in from right to left. And if you look at the pin hole, it's pretty obvious. Okay. We got a little bit of a sticky spot on it sometimes. All right, drop it back in. Put your 4-end wood on. Give it a good squeeze. Tap the barrel band back in place. Okay. Tighten up your barrel band screw. Perfect. All right. Safety function. Works good. Okay. So that's 30 carbine. Good grief, we're at 40 minutes, guys. I am sorry. I hope this was helpful. Again, apologize for the length of it. There was just a lot to go through. So just a quick recap. The two thread pitches for this that are important are the half, I believe it's 32 threads per inch, maybe finer than that, but it's half 32 for your gas block and your retainer nut. Your thread tenon here on your barrel going into your receiver is a 3/4 20. Get a headspace gauge, check your headspace. It's probably going to be best not to mix commercial and mil-spec parts because you may run into some issues like this guy did, like we can't use this barrel. So hope that was helpful. Hope you found it informative. Look forward to seeing you on the next one. This is Josh, Mask Gun Works. Have a good one.